In this video, I'm going over our practice and review that we did today in preparation for our next quiz, which is tomorrow. So here with these first few, we're focusing on our rational expression. With this first one, notice how we are just simplifying. I'm going to focus on my numerator first to see if I can factor, which here I notice I can because there's a GCF. Here between 2 and 4, I have a GCF of 2. But notice how they also both have an x term. So I'm going to take out 2x. So now when you take out 2x, 2 divided by 2 is 1. So we still have 1x. Then plus 4 divided by 2, which is now 2 here. So now I've got x plus 2. Then in the denominator, here I have my trinomial, right? Like an ABC. So I'm now going to go right into parentheses because A is 1. When numbers multiply to get 2 and add to get 3. 2 and 1. So now focus on with the simplifying we can cross out. I see that I can cross out x plus 2. So I am left with simplified form 2x over x plus 1. Now in number 2, again, we are simplifying. So here I'm going to focus on the numerator. I can factor that because this is a difference of 2 perfect squares because I can take the square root of both. So like for example, here in my numerator, now I have square root of x squared, which is just x. Square root of 64 is 8. So this is x plus 8 times x minus 8. Then in the denominator, when I'm factoring, I notice here, anytime I have a negative out in front, I'm going to take negative out. I also have just an x here that can also be taken out. So I'm going to take out here and factor out negative x. So now here I've got 1x. Now remember, right, when taking out a negative, we're changing the sign. So this is now not a negative, this is a positive. So now positive 8 because we took and factored out that x. Now for those who are like, well, how am I going to get that negative? Well, if you were to distribute, what's a negative times a positive? Negative. So that's how you get back to that negative 8. So now notice here, I can take out or cross out my x plus 8. So here I'm left with a negative value. So I'm going to mark off C and D because those are both positive, but negative and x minus 8. So that's why here the answer was B over X. Question number 3, we're focusing on identifying the two x values that make this expression undefined. So remember, to make a fraction undefined, you cannot take a fraction and divide it by 0. So that means my denominator, so I'm going to only focus on the denominator. So in this case, x squared minus 12x plus 20 cannot equal 0. Now I'm going to go through and solve as if like we were factoring. So I'm going to go through and factor, focusing on factors of 20 that would add to get me negative 12. So that would be 10 and 2, but negative 10 and negative 2. Now remember though, we're identifying what makes this undefined. So setting equal to 0 or not equal to 0. That means again, changing the signs, x cannot equal positive 10 and positive 2. That's why the answers were C and E. Question number 4, this is all in function notation. Notice how here, what are we doing? We're multiplying. So no need for keep, change, flip because it's given to us as a multiplication. So I'm going to go ahead and set this up. So my f of x times my g of x. So again, right, remember, no need to flip because this is multiplication. Now I'm going to go through and factor, starting with my numerators. So here, I notice I have a GCF. I have a GCF of 4. So when I take out that 4, factor it out, 4 divided by 4 is just 1, so 1b. Then 16 divided by 4 is 4. Then going to my next, can I factor that? Yes, because it's a difference of 2 perfect squares. So that's b squared, then minus 4. So that is b plus the square root of 4, which is 2, and then b minus 2. Then the denominator. So that's just my numerators. And remember, right, we're just multiplying straight across. Now my denominators, notice how they're both a trinomial. So I am going to go into my factoring. The first, a is 1, so I'm going to go straight to parentheses. What multiplies to get me negative 18 and adds to get me negative 7. So focus on factors of 18. So in this case, I'm going to use 9 and 2. But because I need negative 7, I'm going to have negative 9 and positive 2. And always check to make sure if you need to in the calculator that adds to get you negative 7. Then same thing here. I'm going to go straight to parentheses, the second denominator, because a is also 1 again. So focusing on factors of 8 that add to get you negative 6. So factors of 8, 4 and 2. But because they have to add to get you negative 6, negative 4 and negative 2. So now we can start crossing out to simplify. So here I see b minus 4, b plus 2, and b minus 2. So here we're just left with final answer 4 over b minus 9. So question number 5, we're now dividing. So now when dividing, we do need to keep, change, and flip. So keep the first, x squared minus 3x plus 2, but we need to flip the second fraction. So now x squared plus 6x plus 5 is in the numerator. Now, just like in the previous problem in multiplying, now I can go through and focus on the numerators first. If I factor, factors. So like the first one, I have a trinomial like an ABC, and a is 1. So I can go straight to parentheses. In this case, what multiplies to get 2 and adds to get negative 3? Well, 2 and 1, but to add to get negative 3, negative 2, and negative 1. Because that would multiply, 2 negatives multiplied, make a positive. Now going to my second numerator, right? Because we're just going straight across. A is again 1, so I can go straight to parentheses when factoring. What multiplies to get 5 and adds to get 6? 5 and 1. Now the denominator. Can I factor x plus 5? No. So I'm just going to bring that down. Then 2x minus 2. Can I factor that? Yes. Because both terms have a GCF, I can divide both by 2. So here now, 2 divided by 2 is 1, so that's just 1x. Then again, minus 2 divided by 2, which is also 1. I'm going to put that GCF out in front here, and then x minus 1. So now we can start crossing out. I have x minus 1 and x plus 5. So that means here in my numerator, I am left with x minus 2 times x plus 1 over 2. So now getting into our spiral review questions. The first is simplifying binomial expansion. So here when you have an exponent of 4, that means I'm going to use the coefficients of 1, 4, 6, 4, and 1. Then list the first term. So notice how this is 2x. So keep that all together in parentheses, 2x. Then the exponent is starting at 4, so count down. 4, 3, 2, 1, 0. Then the second term we need to list. In this case, negative 4. So I'm going to keep that all together again in parentheses as I'm listing out my negative 4. Then with the exponent, now we go bottom to the top. 4, 3, 2, 1, 0. Now we can start simplifying. The first and the last are always the easiest because that's your 1 here. So basically that goes away because 1 times that value is still that value. Anything to the 0 power is also 1. So really we're simplifying 2x to the 4th power. Well, remember, this is 2 also being raised to the 4th power. 2 to the 4th power, 2 times 2 times 2 times 2, giving you 16. That x is also being raised to the 4th power, so 16 x to the 4th. Then my last term here, Notice how we've got also 1. So that's going to, again, just go away. And anything, even with the variable, right, raised to the 0 power is also 1. So that also cancels out. And now I just have to solve or simplify -4 to the 4th power. So that's going to give you, make sure you put that correctly in your calculator inside parentheses because of the negative value, and you get a positive 256. Now let's go through and continue here. So starting with the second term, here I've got 4 times. So 4 times, that is 2 being raised to the 3rd power. 2 to the 3rd power is 8. Then x to the 3rd. So x cubed. But still times -4 to the 1st power, which is still just -4. So notice how here you do need to multiply 4 times 8 times -4. So this term now is going to be -128, x to the 3rd. Let's go to the next line. Here we have 6. So 6 times. Well, that's 2 now being raised to the 2nd power, which is 4, and x to the 2nd power, which is x squared. But then don't forget times, that's -4 to the 2nd power, which is now positive 16. So now here to solve, you now need to multiply 6 times 4 times 16. So in this case, this next term is 384 x squared. Then this 4th term here, we've got 4 times. So 4 times. Well, that's just 2x to the 1st power. So that still stays 2x. 2 to the 1st is just 2, and x to the 1st is still x. But we do have -4 here being raised to the 3rd power, which is -64. So now here, to simplify, we now need to multiply. We need to multiply here 4 times 2 times that -64, which in this case now you will get -512x. So the final polynomial is 16x to the 4th minus 128x cubed plus 384x squared minus 512x plus 256. The next two problems here are with our I to the higher power. So with number 7, this is multiplying. So I notice here I've got coefficients of -10 and -4 that I need to multiply. So -10 times -4 is positive 40. Then here I have I, but remember when multiplying, we don't multiply the exponents, we add the exponents. Remember this has an exponent of 1. So when adding the exponents, now you have a final exponent of 20. So now when you divide using the quarter method, so dividing by 4, you get a whole number of 5, which is the same as 5.00, which is 0 quarters. So here when we have 40, we're going to now multiply that by I to the 0. And I to the 0, anything to the 0 power is just 1. So 40 times 1 is 40. That's why the answer was B. Now in number 8, you are raising both the 9 and I to the 5th to the 3rd power. So 9 to the 3rd power. So that's 9 times 9 times 9. That will get you 729. Then now we have our power to a power. So remember, I think like parentheses. Now I'm going to multiply. So 5 times 3 is 15. Now again, do the quarter method. When you divide by 4, you get 3.75, which is 3 quarters. So I've got 729 still, but we're now going to multiply that to I to the 3rd power. And I to the 3rd power is always -I. So 729 times -I is negative 729i. Question number 9 is asking which quadratic has two complex solutions. So whenever you have complex, think about a complex number. What does a complex number always have? Imaginary. So we're looking for which of these has two imaginary solutions, meaning we are again using our b squared minus 4ac, but that means if I need two imaginary, and that means this answer has to be negative. Now I'm going to go through and identify. However, our equation has to equal 0. So what I first need to do here is for A is I need to add 9 to both sides. So that's really x squared minus 6x plus 9. Now I can identify my A, B, and C. So b squared negative 6 squared minus 4 times 1 times 9. Now when I solve this, simplify that, you get 0, but we need negative, so the answer is not A. Now I'm going to go to B. Notice here I need to add the 8x to both sides. So now I've got x squared plus 8x plus 12. Now I can identify my A, B, and C because it's equal to 0. So here I've got 8 squared minus 4 times A times C. So now when you put all that in the calculator, you're going to end up actually with a positive. You end up with 16, but we need negative, so the answer is not B. So now let's go to C. Again, add 7 to both sides of the equation. So now you have x squared minus 5x, but plus 7. Now I can identify my A, B, and C because it's equal to 0. Now I can go through and solve the discriminant. So negative 5 squared minus 4 times 1 times 7. So now when you solve this, you should get negative 3. So that's why here the answer was C. Question number 10. We're simplifying, but notice this is not in standard form, the denominator. So I'm going to rewrite this as 3i over, that should be negative 8 plus 5i. Now I can multiply by the conjugate. Well, what's the conjugate? Always change the sign of the imaginary. So this is negative 8, but now minus 5i. That is the conjugate. So negative 8 minus 5i. Now when you multiply 3i times negative 8 and distribute that 3i here as well. So I've got negative 24i and 3i times negative 5i. They both have I, so negative 15i squared. So then remember, right, anytime you have that I squared here, I squared is always negative 1. So two negatives now make a positive. So this is positive 15 minus 24i. So from the signs here, I can already tell that my answer is B. Because also notice, test taking strategy, they all have the same denominator, which is 89. Because again, 8 times 8 is 64. 5 times 5, 25, and we always add in the denominator. So that's how you still get that 89. Now question question number 11, you're using these two functions. So notice how here we are subtracting, but watch the order. So this says g of x. So where's g of x? Right here. So I need to first have 2x plus 6 minus now f of x, which is here. 2x cubed plus 12x minus 5. Now distribute the negative or negative 1 before you start subtracting. So 2x plus 6, but now minus 2x cubed minus 12x and plus 5. Now combine like terms. I see only this x cubed, so negative 2x cubed, right? Keep the sign in front. There's no x squared, but I have 2x minus 12x, negative 10x. then 6 plus 5, giving me 11. Now number 11b, notice how you have the fraction bar, so this is division. So we are dividing 2x cubed plus 12x minus 5 by 2x plus 6. So because of the coefficient of 2 here, we do have to do long division. So I'm going to set up my long division here with my divisor. Now always check, do we need 0? Are we missing a term for division? Yes, because notice how the x's go from 3, 1, nothing. So we're missing the x squared term here. So always with division, check to see if you need a 0. So I have 2x cubed, but now plus 0x squared, then plus 12x minus 5. Now I'm going to go through and divide first into first. So 2 going into 2 one time. We have 3 x's, but we're taking out that 1x, so now x squared. So now when you multiply, right, remember that matches up. 1 times 2, there's your 2x cubed. But don't forget to multiply that 1 by positive 6 here. So 1 times 6 is 6 and x squared. Then before you combine, change the sign. So negative and now negative 6. So that's 0, but 0 plus that negative 6, negative 6x squared. Then bring down 12x plus 12x. Now I divide again. First term, 2, now into the new first term, which is negative 6. So 2 going into negative 6 is negative 3, and now 1 less x, so negative 3x. So now when you multiply, right, negative 3 times 2, there's that negative 6 and x squared. But don't forget to multiply the negative 3 to positive 6 again. Negative 3 times 6, negative 18x. Now before you combine, change the sign. So that is a both now positive. We're adding. So that gives you 0. But 12 plus 18 is 30. So 30x. Then bring down the last term, negative 5. Now again, we divide first term, which is still 2, but into the new first term, which is now 30. 2 goes into 30, 15. Notice how no more x's are needed. So now when you multiply, 15 times 2, there's your 30. Don't forget to multiply the 15 to 6. So 15 times 6 is 90. But here, don't forget before combining, change the sign. So now that's negative and also negative 90. So canceling out, and you get negative 95. That is your remainder. So negative 95 over 2x plus 6. Now, here's another division problem. And for some of you, people have been asking, well, do we do what we've been doing with our factoring, like with the rational expression? So see how we're starting with x to the third? In this case, treat this like this is division. Notice how I'm dividing by just x by itself, so we can use synthetic division now. So I'm going to set up my synthetic, but remember, change the sign now, so not negative 3, but positive 3. And then again, because we're doing division, do we need 0? Are we missing a term? Yes, because notice how it goes with our exponents for x, 3, 2, and then nothing. So what are we missing? Our 1x here. So I have 4, then negative 6, right? Don't drop the sign, right? Keep the sign in front. Then 0 followed by 1. Then always bring down below that first term. Now we can start. Multiply below. 3 times 4 is 12, and add above. Negative 6 plus 12 is 6. Multiply again. 3 times 6, 18. Add above to get 18. 3 times 18, 54. So we have a remainder of 55. So remember, that is your remainder. So the final answer, remember here, if I started at x cubed, then we start at x squared. So this is 4x squared plus 6x plus 18. Don't forget the remainder, plus 55 over x minus 3. So now our last two questions pertain to our graphs of our polynomials. So here you had to identify all of the true statements. So the degree here, let me add our arrows here. So the degree of the function is even. Well, I agree with that part because both arrows are going the same direction, but they're both pointing down. But this says positive, so that's wrong because this is negative. Then here the degree is even, which again I agree, with a negative leading coefficient. So that's why the second one is true. Now here we have our end behavior. So as x approaches positive infinity, so as we're going to the right, towards positive infinity, what direction is the right side of our graph going? Down to negative infinity. So this statement is true. So then as x approaches negative infinity, so now as we're going to the left, towards all the negative, so negative infinity, what direction is the left side of our graph going? Down towards negative, but this says positive, so that statement's false. The degree of the function is 4. So this goes back to identifying what is the multiplicity for each of our zeros. So I notice here I have my slide, my bend. So this is a multiplicity of 3, but this is a slice here. So this is a multiplicity of 1. So it's 3 plus 1, 4. So the degree is 4. And it's an even number. And we said that this is even because both arrows are going down. So that also matches. So now let's check here to see if the equation should be represented by that. So here again, we have our x at 0. So that multiplicity of 3, so that's x to the third. Then remember, when writing factored form, we change the sign. So I'm not going to put x plus 2, I'm going to put x minus 2. But notice they put plus 2, so it was only these 3 statements that were true because they didn't change the sign here to x minus 2. So now question 14. Given the intervals, which of these are negative, so below the x-axis, and decreasing, so going down, reading the graph from left to right. So looking here at A, for example, this is our x values. So from negative 1.117, so right here, so from that value here to 0. So we're talking about this portion of our graph for A. Well, notice how it is below, so the values are negative, but read it left to right. What direction is our graph going? Up towards positive infinity, or it's increasing. So the answer is not A because we need decreasing. Now let's go to B. B is negative 3 to negative 2. So negative 3 here to negative 2. So notice how this graph is going on and on and on. So it's going to eventually reach negative 3 and even go past it. So this is the portion of the graph we're talking about, up to negative 2. Well, notice how it's below the x, so we have our negative values, but read it left to right. Don't look at the arrow, how it's pointing down, because that's the end behavior. If you were to read this left to right, what direction is our graph going? It's increasing, it's going up, so it's not B. Now let's check C. So C is focusing on from 0 to 0.717, which is right here. So this point starting at 0. So it's this section of our graph. So notice how, again, below the x-axis, so the values are negative, reading left to right, what direction is our graph going? It's going down now. It's decreasing. So that's why the answer was C. So then just to make sure, for those who saw or looked at 1 to 2 for D, that's 1 to 2, which notice how this part of the graph is positive because the this portion is above the x-axis. So that's why here the answer was not D.